In this video, we are going to talk about representations of functions as power series. So the first thing that we're going to start is with a geometric sequence. And a geometric sequence looks something like this. So we have the series, so we have the sequence a r to the n, and the series will be the sum from n equals 0 to infinity. And we know that if r, the absolute value of r is less than 1, this will converge. And the way that we find the value that it converges, we just take the value of a divided by 1 minus r. Notice that before we had n minus 1 on the top, but since I'm starting at n equals 0, then I'm just changing it. So in this case, my a value, I'm going to set it equal to 1. And I'm going to say our r value is going to be equal to x. So I'm going to introduce this function, or this value of x. X can be any value. Well, not any value, but I'm going to plug that in, and I'm going to get summation as n goes to 0 to infinity. And I'm going to have 1 times x to the power of n. Okay, and here our x value, notice it can't be anything, it's going to be less than 1. I'm just basically mimicking what's on top here. So if I were to use the infinite series formula, this will be, well, a was equal to 1 over 1 minus x. So what I'm doing here is that I am basically representing this function. So let's say that this is a function, f of x is equal to 1 over x. So 1 over 1 minus x. And what this says is that I can represent this function as a power series. So we can represent the function f of x equals 1 over 1 minus x as a power series. So if I, which is really, really crazy, because you're basically taking a function and making it not continuous, or making it into a individual sums, which is actually really, really cool. So in this case, x will converge as long as, or this series will converge as long as the absolute value of x is less than 1. Okay, so let's do a couple of examples, because this is going to be our key. So our key right here is this, that I can represent a function that has the form of 1 minus 1 over x, 1 over 1 minus x as this power series. So here's my example. My example is find a power series. Oops. Representation of the following functions. Okay, so here's going to be my first function. So let's say we have g of x is equal to 1 over 1 plus x cubed. So we want to find a power series representation of this particular function. Well, what do we know? What we know is that I can represent a function that looks like 1 over 1 minus x as the sum from n goes from 0 to infinity of x to the power of n. That's what I know. Now, that's not what I have. What I have instead is 1 over 1 plus x cubed. That's what I got to work with. So is there a way that I can make this thing kind of look like this? Well, first I need a negative. So something that I can just write this as is 1 over 1 minus negative x cubed. Because a negative and a negative is going to give me a positive. Well, now if you notice here, this x that I have here can just be substituted by plugging in this negative x to the cubed. Because this x corresponds to this x, so I can actually represent this as the sum from n goes to 0 to infinity of whatever's in the inside to the n power. Now, here we just had x. I'm just going to plug in x here to the n power. Here we have negative x to the third. So guess what I'm going to plug in there? I'm going to plug in negative x to the third power. Okay. Now, if we look at a radius of convergence, okay, so the absolute value of x has to be less than 1. Well, here it was because you had an x here. In this case here, the absolute value of negative x cubed has to be less than 1. Okay, so all I'm just doing is mimicking this. All right, so let's try to simplify this a little further. So this is going to give me the summation from n goes from 0 to infinity. Notice that I can separate this as negative 1 to the power of n, x to the third to the power of n. Okay, I'm just taking that out. Provided that, and I can do x to the third power to the 1. Then I have the sum from n goes from 0 to infinity of negative 1 to the, and then x to the power of 3n. Okay, provided that x is less than 1, because I can cube root both sides and that's what I get. So the power series representation of this particular function is going to be this. Okay. All right, and here is my radius of convergence, or interval of convergence. Okay. All right, now it's not always going to be absolute value of x is less than 1. It can be a little bit different. Okay, so let's try another problem. So let's say we had h of x is equal to 2x squared divided by 1 plus x cubed. Okay, so let's first figure out what we know. So what we know is that 1 over 1 minus x can be represented as a power series of this form, provided that the absolute value of x is less than 1. So now let's try to make this h of x function into something that looks like that. So we have this h of x, which is equal to 2x squared over 1 plus x cubed. Okay, so let's try to make this look like that. Well, one thing that I can do, I can just put this on the side, 2x squared times 1 over 1 plus x cubed. Because this is just, I can put this over 1, I can just multiply it, and that's what I get. So now this thing is just the original function that I just had up here. So this can just be written as 2x squared times 1 over 1 minus negative x cubed. Okay, and here we are providing that the absolute value of x is still less than 1. Okay. Oh no, just kidding. Okay, so now we can do the power series representation. So this is going to be 2x squared. This I can represent it as a power series summation from n goes from 0 to infinity of negative x cubed to the n power, and then provided that x cubed to the negative is less than 1, which we already knew. So this is going to be 2x squared. We already knew what this was. This is going to be this thing. So this is going to be the sum from n goes from 0 to infinity of negative 1 to the n, x to the 3n, and then provided that x is less than 1. So now what I can do is that I can take this thing and put it inside. So I'm going to have the sum from n goes from 0 to infinity of negative 1 to the n power times 2x squared times x to the 3n. So what I'm going to get is the sum from n goes to 0 to infinity, negative 1 to the n. Then I'm going to have this lonely 2, and then this thing I can just go ahead and multiply, and that's what I'm going to do is add these things together, x to the 3n plus 2, provided that x is less than 1. So this is going to be my power series representation of the function h of x. Okay. All right, now let's do one last problem. So let's say we had f of x is equal to x cubed divided by 3 minus x squared. Okay, so let's write down what we know. And what we know is that I can represent 1 over 1 minus x as the sum from n goes from 0 to infinity of x to the n, provided that absolute value of x is less than 1. So now let's look at our function, f of x, which equals to x cubed over 3 minus x squared. And let's try to make this way. So I can take this x cubed, put it on the side, 3 minus x squared. Now I have a problem here. because in the previous problems, I only had a 1. Okay, see like how I have a 1? So I had a 1. Now I have a 3. Well, I don't want that 3. I want that to be a 1. So one of the logical things to do is just to factor out a 3. So you have x cubed times 1 over, so let me factor out a 3. So when I factor out a 3, I'm going to be left with a 1 minus x squared over 3. And you can see that if I distribute this back, I'm going to get back to where I started. So I can then write this as x to the third divided by 3 times 1 over 1 minus x squared over 3. Notice that this can be its own entity. And now this looks just like this, kind of. So I'm going to have this x cubed over 3. Then I'm going to have the summation from n goes from 0 to infinity of the x value. In this case is going to be whatever's in here, which is going to be this x squared over 3 to the power of n. Provided that, well, since there was an x here, and I had it there, here I'm going to have this x squared over 3, and then less than 1. Okay, so now what is this going to give me? Well, this is going to give me x cubed. Well, the x cubes can go in the front, so I'm going to have summation from n goes from 0 to infinity, x cubed over 3 times x squared times n divided by 3 to the n. And then here I can multiply the 3 over, so I'm going to have absolute value of x squared is less than 3. So let me clean this up a little bit more. Sum from n equals 0 to infinity. So the top part is just going to be x to the 3 plus 2n. The bottom part is going to be 3 to the 1 plus n. And then here, I can just have it as x squared less than 3. I take the square root to both sides, so the absolute value of x is less than the square root of 3. Okay, so this is going to be my interval of convergence. Now, if you really want to find the interval, the absolute value of x is less than square root of 3. Notice that I can just write it as negative square root of 3 and then square root of 3. Okay, so that's what power series representations look like. You just want to manipulate something that looks like this so that I can represent it as a power series.